Okay, right now. I'm sorry. Can you hear me right now?
Oh, yes.
Okay, very good. Okay, I'm sorry. I forgot to check the switch button. Yeah. Okay. It's supposed to be on here. Okay. Okay. Never mind. Okay. Right. So, thank you for your response. I hope all of you can hear my voice. And then, how about my presentation? Can you see my presentation as well?
Yes.
Okay, Jin Ying, thank you. Pei Wen also, thank you very much. So, let us start the lesson for today. Okay, if you still remember last week, okay, Xing Tong, okay, welcome. Last week on Thursday last week, we have no online classes, but I need you to open to page 229 and 230. Okay, topic 8.2. Okay, the properties of light. This is very short topic. What you need to remember just to understand what is the properties of light. Do you have any question about that particular topic or no? This one. 8.2, just the properties of light. Okay. Do you have any problem? Do you already do the exercise that I gave you last week? Huh? If I'm not mistaken, I asked you to do the exercise on your workbook, page 74. Page 74. Okay. Any problem about this topic? 8.2, the properties of light. Any problem, class?
No.
No problem. Yeah. Make sure you understand. Just list up the properties of light. Number one. Okay. I just um, give you the brief what we call lesson about topic 8.2. All right. Okay. Just a brief introduction on page on what we call topic 8.2, the properties of light. Okay, now I want to ask you, what is the first properties of light you learned in 8.2? Anybody can what we call tell me, because you said you have no problem, right? So what's the first properties of light according to the textbook here? Okay, right. So the first properties of light is the speed. Okay, the speed of light. It is what? Um, 3 times 10^8 meter per second. So this is the first properties of light. It is about, or it is equivalent to about 300,000 kilometer per second. Can you imagine how fast is it? 300. How to remove this? Okay, it is about 300 kilometer per second. Number one, that is the first properties of light. You must understand and try to identify or memorize the speed of light. Okay. How about the second one? The second one, okay. You must remember the sun or the lights travel in straight line. The lights travel in straight line. That is the second properties of the light. Okay, class? Okay, what is this next one? Formation of the shadow. So you can see maybe the properties number 3. It can form shadow. Form shadow from opaque object. So what is opaque over here? What's the meaning by opaque? Okay, can you see my presentation over here? You tell me if you cannot see, you just tell me. Okay, this is the formation of shadow, class. What is mean by opaque? There are two terms you need to understand here, meaning that number one is what we call an opaque object. Opaque, O-P-A-Q-U-E. Okay, what is the opaque object? Opaque object is the type of surface or the type of object that the sunlight or the light cannot pass through it. This is what we call by opaque object. O-P-A-Q-U-E. Alright. The opposite of opaque is, anybody can tell me what is the opposite word for opaque? What is the opposite word for opaque? Okay, for example here, umbrella surface, this is umbrella, is an opaque object. Why? Because the light from the sunlight, for example here, cannot penetrate or cannot pass through the object. This is what we call opaque. Opaque object. And then the opposite terms of opaque is transparent. Transparent mean the object can go through. Okay, class, very easy like here. What is the object that can the light can pass through the object? What is the type of object you think?
Glass.
Yes, very good. For example, the glass, right? Glass glass is what we call is a transparent object. Okay, because the light able to pass through the object, we call it transparent. Opaque object, the light cannot go through or cannot pass the object. For example, wood. Wood is an opaque object. For example, another example is iron. Iron is also, we call it an opaque object because the light cannot go through. And then what happens when the light cannot go through the opaque object, they will form a shadow. For example, like this. Right. If you have an opaque object, for example, never mind. If you have an opaque object over here, for example, this is an opaque object. Okay. If the object here is O-P-A-Q-U-E, and then when there is a sunlight over here, for example, I just draw the three lines over to represent the lights. What happened to the lights? The lights will be reflected away. And then what happened behind the object? What is formed behind the object? There will be a what? There will be a shadow. Okay, there will be a shadow. When there is a light here, right, the light will reflect it through an opaque object, and then there will be a shadow over here. All right, this is for opaque object. Okay, so if the opaque is transparent, is the object is transparent, what happened? Okay, if the object is transparent, for example, I just draw another block of transparent object. Maybe this is made from transparent glass. Okay, not opaque, transparent. So if the light shine through it, okay, it able to pass through the object. Got shadow or no shadow here? If the lights, okay, yes, repeat, please repeat. Is the if the light, okay, there will become, okay, very good, there will become no shadow. Because light can go through the transparent object or the transparent, for example, the object here is the glass over here, so you can see no shadow. But if the light cannot go through the opaque object because of the material itself. It will cast a shadow. Opaque objects such as what? Such as wood, such a stone or rock. Any what we call object that cannot that do not let the light pass through it. This is what we call an opaque object, and then it will cast a shadow. It will cast a shadow. Okay, and then the shadow will form according to the shape of the opaque object. Okay, if the shape of the object is rectangle, then the shadow is rectangle. Yeah? If the shape of the object, for example, the shape of the human, okay, the shape of the human being, for example, over here, the shape of A lah, the shape of A, for example, this is object, the opaque object, the shape of the A. So the shadow it will cast also follow the shape of the opaque object. Okay, this is what we call the formation of shadow. Okay, this is the formation of shadow. Okay, class, can you understand this? Right. Next one. Okay. Shadow becomes short in the afternoon. Next one, shadow will become short in the afternoon, and long in the evening. Can you understand this? Why the shadow becomes short in the afternoon and long in the evening? Because of the what of the sun?
Distance.
The distance of the sun or the position of the sun? Which one you think? The distance of the or the position? Huh? Okay. Can you understand this? Let me draw it for you. Okay. For example, I draw here a picture of a person over here. All right. This is a person over here, and then this is the Earth. Right. At the afternoon. What is the position of the sun in the afternoon? Is it on A, B, or C? The position of the sun in the afternoon. Which one? A, B, or C?
B.
B, right. So B is the position of sun in afternoon. Maybe about 12 to about 1 p.m. Right. Okay. So where is because of the light travel straight line. You must remember, the light will travel straight line. So the lights will travel from the center position into the person over here. And then what happened to the shadow? The shadow of the guy over here, the person over here will become shorter. The shadow will become like this. Okay, it will become shorter. So it will cast shorter shadow. You understand this? Can class?
Yes.
Okay. Okay, right? Okay, they will become shorter shadow. Okay. So what happened at A and B? A and B is what? During the evening, long in the evening. Okay. Maybe early in the morning, when there is a sunrise, and then late in the evening, maybe when there is a sundown, when there is dawn. Okay. For example, if I take A over here, so this is the position here lah. This is the position. This is the position of sun in evening, for example, in evening. Maybe about 4 to 7 p.m. Okay, because of the light casting, the light from the evening, the position of the sun is what we call is changing. So you can see the shadow over here the shadow of the person over here will become what? Will become longer or shorter? The shadow of the guy over here. There will be a longer. Yes, very good. There will be a longer shadow cast by the sun in the evening. In the evening or in the early in the morning. Early in the morning also can lah. Maybe about 7, 8 or 9 a.m. You can see the shadow is also longer. And then at the middle of the day, maybe about in the afternoon, maybe about 11 to 1 p.m. 11 a.m. to 1 p.m. you can see the shorter shadow because of the position of the sunlight. Okay, this is what we call the how the light casts the shadow according to the time. Okay, maybe on the afternoon shorter shadow, in the evening they have a longer shadow. Okay, class. Right. Next one. Okay. Another properties of light is it can disperse by water droplet to form a rainbow. This I will be learning about this in next topic. Okay, for the formation of the rainbow. Okay, and then also I ask you to do the formative practice 8.2. I hope you already finished it, and then your workbook page 74. Okay, class. All right. So today 8.3. Can we continue 8.3?
Yes.
Okay, very easy. I will go very fast. So this is the reflection of light. So what is the reflection of light? Okay, number one, you must understand the characteristic formed by a plane mirror. We are just using plane mirror. Okay, in 8.1, if you still remember, how many type of mirror, class?
3.
3 type of mirror. Very good. Number one is plane mirror. Number two is concave mirror, and number three is convex mirror. Okay, so in 8.2, we just focus the reflection of light in a plane mirror only. In plane mirror. Maybe after you go to Form 4, Form 5, you learn about physics, then you'll be learning about the reflection of light in convex and concave mirror. But in Form 1, just in plane mirror. Very easy. Okay, number one, the characteristic of image formed by a plane mirror, and then the law of reflection, and then the ray diagram. Later on, we try to draw the ray diagram to show the reflection of light, and then the daily life solving problem with the application of reflection of light. This is later on. We go one by one. Okay. Number one, characteristic of image formed by plane mirror. How many characteristics over here? How many characteristics? There are 1, 2, 3, 4, 5. Yeah? There are 5 characteristics of image formed by a plane mirror. Remember, we are still using plane mirror. Okay, the first one, the image is upright. I will try to zoom it a bit for you. Yeah. Okay. All right. Okay, this is the first one. The first one, the object is upright. It cannot be inverted. Okay, it cannot be inverted. Meaning horizontally, not horizontally. Horizontally, it cannot be inverted. The image is upright. Okay, number one. You must remember, number one, the image is upright. Okay, number two. This is number two. Okay, so if you can see here the characteristic on number two, the object size, capital H, is same or equal to image size in the mirror, small h here. Okay, I think you already know about this. You still remember the image formed in the plane mirror? The size is same, right? So, for example, if the height of the boy here is about 150 centimeter, so what of the height of the image formed in the mirror? What is the height?
150.
Okay, very good, very good. So thank you for your response, yeah, class. Yeah, very good. Also, 150 centimeter because you are using plane mirror, plane mirror. Okay, and then how about the OA, the object distance? OA is object distance is equal to the image distance. Image distance meaning the image that form on the plane mirror. For example, if the distance of OA is 2 meter, object of the distance, and then the image distance is also, class?
2
Yes, very good. Also 2 meter. Okay, meaning what I mean is the distance, the object distance from the real object to the plane mirror, and then the mirror to the image form is same distance. Okay, same distance because we are using plane mirror. We are using plane mirror, same distance. You just remember that this, same distance, same size. That's all. Okay. Okay. So what is the characteristic number 3? Okay, this is characteristic number 3. Right. Characteristic number 3 is laterally inverted. Laterally inverted, not horizontally. Okay. It will stay upright, but laterally it will be inverted. For example, the B, the letter B on our right, on our left is the object, the real object. This is the real object, yeah. This is the real object, real object, and then this is the image. I will draw you lah. I will draw you the line lah. So this is plane mirror. Plane mirror. Okay, this is the plane mirror. Okay, all right. This is the plane mirror. So what happened to the image on the plane mirror? We call it laterally inverted. Laterally. Laterally mean it is not horizontally. It is not horizontally. It is what we call. This is horizon. This is horizontally and laterally. Okay, can you understand this? This is the real object, and then the image form is laterally inverted. Okay, how about the object distance OA and OB? Still same or still different? Different or same? The distance? What you think, class? Distance? Yes, very good. Distance always same. Okay, but the size always same. Can you see the size here? For example, if the height of the real object B is 2 centimeter, and then of course the size of the image form is also 2 centimeter. But the only difference, that's what we call it laterally inverted. Maknanya dia terbalik. Okay, this is what we call laterally inverted. For example, how about the letters A? If I can draw the picture here. Okay, if I can draw the picture here, how about if I have a letter A over here, for example. Letter A. Okay, this is A. This is the real object. Okay, and then this is the plane mirror. Plane mirror. M-I-R-R-O-R. Okay, this is plane mirror. Okay. What is the image form in the plane mirror? Is it because of the what? I just want to show you lah. Because of the capital A, sorry, the object here is symmetrical. If symmetrical, if the object symmetrical, how to spell it? Symmetrical. Okay, if the object is symmetrical, so there is no problem, right? Because if the object is symmetrical, meaning the left side and the right side is same, so there is no problem. The image formed on the plane mirror is also like this. Right? Remember, just the size is same, yeah? You do not confuse with the size over here because I'm just drawing it. If you use plane mirror, the size will be same, yeah? You must remember that. I'm just drawing, not following the size, yeah? Okay. How about if I use letter, for example, letter K. Letter K. If I try to use letter K over here. Okay, this is the real object. Okay, this is the real object. And then this is the mirror. I just draw a bigger mirror. This is plane mirror. Okay. Wait a minute. Alright. Wait a second, Okay. Alright. So what is meaning by laterally inverted? So this is the real object. This is the plane mirror over here. So you can see that it will form like this. Okay, can you understand? This is what we call laterally inverted. Is it okay, class?
Okay.
Laterally inverted like this. Okay, my question now is, again, if you still remember, I think very easy one. If the size of K here is 5 centimeter, what is the size of the image inside the plane mirror?
5 centimeter.
Also 5 centimeter, very good. Okay, and then how about if the distance here is about 10 centimeter? So what is the distance between the OB? OA here is 10 centimeter. Yes, very good. So the OB here is also 10 centimeter. Okay, but the image is laterally inverted. That's all. Is it okay, class? Can you understand this? Okay, very good. So we continue. Okay, and then the last characteristic of image formed on the plane mirror is virtual. Not real image, virtual image. That's all. Okay, right. Next one, the law of reflection. 240. Okay, the law of reflection, you must understand the term we use first here. We need to have an angle of incident. We represent by the small I letter over here, and then the angle of reflection. This is the small letter R. Angle of incident and angle of reflection. Okay, what is the angle of incident? What is the angle of angle, not angel. Okay, angel is the malaikat, the angel. Itu malaikat lah. This is angle. Angle of incident, I, and then angle of reflection. So I will show you some what we call image over here. Okay. This is how we draw an angle of incident and an angle of reflection. Okay. Angle of incident is always like this. Incident ray is the sources of light. If I can draw another line over here, This is usually the sources of light. The sources of light. Maybe from where? Maybe from flashlight. Yeah? Maybe from laser. Okay, this is the sources of light. So we call it incident ray. We call it incident ray. Okay, and then where is the angle? We calculate the angle of incident ray is here, and then we write it as I. I is incident ray. Okay, and then this is the reflected ray. You must also notice the arrow over here, the direction. The direction of the arrow is like this, meaning that it is a incident ray, or the sources of light, where the sources of light is coming. Okay, and then when the lights hit the surface of the plane mirror, it will be reflected. This is where the reflection of light taking place. Reflection of light happen at the surface of the plane mirror over here. Okay, and it will bounce off the surface of the plane mirror, and then it will become reflected ray. And then how you want to write it, and where is the angle of reflection is over here, right? And then you must write R. Okay, but for plane mirror, very easy. I is equal to R. Okay, very easy one. For example, if the what we call the incident angle is 50 degree, so very easy for you to remember, the reflected ray also 50 degree Celsius. 50 degree, not Celsius, I'm sorry. Celsius is for temperature, degree is for the angle of the what we call the ray. Yeah. Can you understand this? I give you the example, yeah? I'll try to give you the example. All right, where is this? Okay. Okay, can you see my presentation over here?
Yeah.
Okay. Because of this diagram over here, this diagram include the refraction of light, so I need you to ignore the refraction angle. Never mind. I will try to take another simulation. Okay, like here. Okay. We try to, oh, cannot zoom in. Okay, never mind. Right? So this is what we call a law of reflection. You can see here, by using a laser, it will bounce off the mirror. So this is what we call the reflection of light. Okay. So at the middle, exactly at 90 degree, okay, class, exactly of 90 degree over here, this is what called a normal line. Okay, normal line is 90 degree. Okay, usually we draw the dash line lah, yeah? We draw the dash line. We try to make it smaller. Okay, we draw a dash line, indicate that this is the normal line. Normal line that divided the surface over here, and then you must remember this is at the 90 degree angle. Okay, 90 degree here, 90 degree. So you must write, draw the normal line, and then the normal line is dash line. Dash line is like this lah. Yeah? If you have a surface of mirror, for example, like this, so this is what we call the normal line, dash line, garisan putus-putus, and then it is usually 90 degree. Okay, next one. Okay, this is the incident ray. Incident ray, what we call the light sources, where the light sources from. and then this is the reflected ray. Never mind, I will try to give the simulation later on our Telegram group. This is incident ray. All right, this is incident ray. What is the letter? Represent by what letter? Incident ray? Class? Incident ray? What are the letter?
I.
I, right. Okay. This is I. And okay, this is I. Incident ray is I. And then reflected ray is R. Okay, R. And then I is the incident ray. And then the reflected ray is R. Don't forget to draw the direction. Yeah? You just draw like this in order to make sure where is the sources of light come from, whether it is incident ray or reflected ray. Okay, next one. So this is the angle of incident. So this is the reflected angle. Okay. Next one. Very easy one. If the angle of incident is 55 degree, for example, right here, I cannot make it bigger. I cannot zoom it. Never mind. Okay, I hope you can see it later on. You can try. Okay, if the incident angle is 55 degrees, so the reflected angle also 55 degree. That's all you need to know. Okay, class. That's all you just need to know. For example, like here, if I put another, use another angle, for example, here. Okay. For example, 45 degree, 48, 50 degree lah, like here. I hope you can see the simulation here. For example, if the incident ray I is 50 degree, and then so the reflected ray also 50 degree. That's all. This is for reflection of light. Reflection of light. Okay. If I move the incident ray, if I move the sources of the incident, and then also the reflected light also is the same. Okay. Right now, how much is R right now? How much is the incident angle? Can you see it, class? I hope you can see it.
66.2.
Yes, very good. So the I over here is 66.2. So the reflection angle also 66.2. Same. That's all for the reflection of light. I hope you can understand this. All right. So next one. Okay, application. Last topic for today, the application of reflection of light. I think you can read it for yourself. One of the application is the hazard cone over here, and then the signboard. That's why you can see the signboard is illuminating. Not because the signboard has the light, because of the reflection from the light of the car that make the signboard glowing at night. Okay. And then another example is the ambulance. Why the words ambulance over here is spelled inverted? Because if we want to see the letters, the real letters you see on the rear mirror, it will become normal letter. Okay. I think for the application of reflection of light, I think you can read it for yourself. And then if you have any question, you can ask me. Okay. Any question about the reflection of light before we stop here?
No.
No, Okay, if there is no no question, I will stop the lesson here, and then I will try to share you the simulation, the simulation that I just showed you just now, in our Telegram group, and then the exercise for today also I will give the exercise on our Telegram group as well. So if there is nothing to ask, we will see you all again tomorrow at 9, 9 in the morning. So, okay, that's all for today, class. Thank you very much for your focus. You can leave the class now. If you have any question, you just ask me on the Telegram group. Bye-bye. See you tomorrow. Bye.
Thank you, sir.
Thank you, teacher.
Thank you. Thank you very much.